Hello to all listeners. I introduce myself, Dr. Haloui Isman from the Constantine III University in Algeria, Faculty of Process Engineering. I mainly work on the extraction of vegetable oils by new and innovative technology. Today I am going to present to you a part of my work which is entitled Ultrasonic Assisted Extraction of Vegetable Oil from Shea Seeds. Salvia hispanica L. and its antioxidant and anti-diabetic activity. In my presentation, I will follow the following plan. First, I will begin by introducing the context of the study by describing the problem posed and the interests it addresses. I will then present the plan to study and ultrasonic extraction, which is the method of the extraction that we chose for this study. I will then focus on the experimental study to perform, then the evaluation of the biological activity of the extracted oil antioxidants activity and anti-diabetic activity. I will finally end with the general conclusion. Currently, the increased demand for the use of products derived from natural extract is linked to the concern about the harmful effects that synthetic products may have on human health and the environment. The World Health Organization estimates that around 80% of consumers use traditional herbal medicines. A large number of plant species belonging to the Lamiaceae family represent a source of a wide variety of secondary metabolites, such as vegetable oils, phenolic acids, flavonoids. These compounds are widely recognized for their biological antioxidants and even enzymatic activities. In our work, it is interested in a very particular plant which is the shea, Salvia hispanica, which belongs to the category of annual herbaceous plants. It reaches a length of 0.5 meters to 1 meters and a width of 0.3 meters to 0.6 meters. Figure 1 and 2 represent shea seeds and the shea plants respectively. The results of current research on shea grains indicates a high nutritional value, naturally rich in dietary fiber and good fats. They close in particular form 15% to 17% of omega-3, also contain 5% to 10% of omega-6, which gives them a lot of interest. Chia is also a good source of vitamin B1, B2, B3, B8, B9 and E. Chia grains contain the 9 essential amino acids which allow the constitution of proteins, and rare are the vegetable ingredients which join together these 9 amino acids. They also contain high level of calcium, magnesium, phosphorus and zinc. Shea is also a very rich in antioxidants. Principle of ultrasonic extraction. Ultrasonic extraction is a technology of obtaining natural extracts. Ultrasonic waves interact with plant material and change its physical and chemical properties. By disturbing the cell's walls of the plant, a cavitation effect is created and facilitates the release of extractable compounds. Figure 1 shows the devices implemented. The oil-rich solid, in our case the crushed chia seeds, are immersed in a mixture of solvents, water, ethanol, in different proportion. The equipment is equipped with intelligent softwares which allows adjustment, monitoring, and adjustment of the extraction parameters, thanks to the precise control of amplitude, sonication time, and pulse cycles. Figure 2 shows the principle of the phenomenon of ultrasonic cavitation. The steps of ultrasonic extractions consist of very energetic ultrasonic waves move on the liquid, creating alternating cycles of high pressure and low pressure which cause the phenomenon of ultrasonic cavitation. Ultrasonic cavitation locally causes an increase or decrease of the temperature and a local pressure, causing cavitation bubbles to employed on the surface of the solid. Experimental development and monitoring. The figure 1 shows the experimental device implemented. The ultrasonic assisted extraction was carried out in a beaker. For each experimental run, about 15 grams of Shea were immersed in 100 ml of water ethanol solvent mixture in various proportions, and the operating parameter carefully adjusted. Once the operation was complete, the volume of obtained macera was centrifuged for 15 minutes at 8,500 rpm. At the end of the separation, the obtained supernatant was placed in a rotavapor. The solvent evaporated. Thus collected extracted oils was used for the determination of the antioxidant and antibiotic power. Optimization experimental design. A box banking design with the following four independent variables was used: ultrasonic power, number of pulses, extraction time, and ethanol concentration. These variables were coded at three levels, which resulted in an experimental design of 27 experimental points, including three central points. Experimental data were fitted to a second-order polynomial model and regression coefficient obtained. The generalized second-degree polynomial model used in the response surface analysis was as follows, where y is the response value predicted by the model. Analysis of the experimental design and data were carried out using Minitab. The models were predicted through statistical analysis and regression analysis ANOVA, and the fitness of the polynomial model equation was expressed by the coefficient of determination R². The figure 6 shows points which are equivalent ones to the first bisector, which indicates that the experimental values and predicted ones by the model are quite close. The multiple linear correlation coefficient clearly quantifies the goodness of fit with correlation coefficient R squared close to the unit and is equal to 81.10%, allowing us to conclude that the model allows us to reproduce in a satisfactory way the observed values. The main objective of using experience plans is to obtain the value's optimal operating variable to give a maximum response. The value of the operating condition found are amplitude 17%, number of pulsation close to 54 pulsations per minute, extraction time about 30 minutes, ethanol percentage 50%. To this value is optimal. The predicted yield response by the software is 5.48091%. The purpose of the response surface method is to explore the relationship between the variable dependent and independent involved in an experiment's response surface, and the plots of the contours obtained at the end of this modeling are presented in the figure 8. In this observed that the combination of the different factors, a dark green region appears in which the yield increases. The anti-phi radical activity of the various extracts was evaluated by the measurement of 50% inhibitory concentrations, based on the ability of the substance to reduce the dppH radical compared to a standard antioxidant (BHA). The results are evaluated by measuring the absorbance on the microplate by UV, in which an apparent change in color is observed in each test. The analysis of the obtained extract indicates a strong antioxidant activity with an inhibitory concentration 15 equal to 3.22 microgram per mils, compared to the BHA standard EC 15 equal to 6.14 microgram per mils, particularly a double value. The oil has also a strong anti-diabetic activity with a rich inhibitory activity of 105.27 microgram per mils, 35 times more significant than that of the standard acarbose EC15 equal to 3615.93 microgram per mils. This enzymatic activity of the different chia oil extract fraction was evaluated by measuring the ability of the oil to inhibit the enzyme alpha amylase. The present study indicates that box-Banken design was used successfully to optimize the condition of extracting shea oil, with a R-squared correlation coefficient of 81.10%. The analysis of biological activities determined a good antioxidant activity and was considered as a good source of phenolic compounds and also as excellent anti-diabetic activity. Overall, ultrasound-assisted extraction of shea oil has a strong potential of industrial development as a value-added, time-saving, and environmental-friendly process for the preparation of natural strong antioxidants and excellent anti-diabetic activity. Thank you for your time.